The oxides MgO, Al2O3, and SiO2 are used as refractory materials. They tell me a lot of story. Keyword, high melting point, maybe. The last two are gemstone. I don't know about gemstone. If a sample of one of the oxides was provided as a white powder, so you get something white, describe the reaction will carry out on the powder to determine which of the three oxides it was, which is all your period 3 oxide. And we have talked about that, and we all know, right, they are kind of obviously a bit different. Now, these three are all white color. Right, like it on, they're all white. Right. So when given to you, you don't know who is it. Is it MgO, Al2O3, SiO2? So I basically ask you, can you do an experiment in the lab, very simple one, and share with me whether it is MgO, Al2O3, SiO2. Some students tell me do this test. Do what test? Add water and you see whether they dissolve. Very fast one. They tell me. I say, okay, let's take a look. All right. Ladies and gentlemen, MgO, Al2O3, and SiO2. Do you think they dissolve in water? MgO is sparingly soluble in water, remember? Or you can take 3 as insoluble in water. Al2O3 is insoluble. SAM, insoluble. So in case you're thinking of using water, you can't. So what else can we do? Let's finish up. Okay, so first thing, if you can use water, I use it. Makes sense? I just want to identify it. They are all oxides. We are an oxide. So we start using water. What else can we use? Just now we have 1 or 2 questions related to that. This one already. We can use acids or alkali, right? Makes sense or not? So let me run through with you. So first, let's say I add a nitric acid, which will never form precipitate, right? Because all nitric are soluble. I add these to the solid sample. Right, the white solid sample. So when you add, the oxides either do dissolve or doesn't dissolve. Agree? Make sense? Right, so we just write here, dissolve or does not dissolve. Doesn't dissolve. Right, there's only 2 scenarios. So based on your understanding of your 3 oxides, my friend, when it dissolves, it will be who? Who could it be? Who will react with acid over here? MgO, because it's a basic oxide. But it could also be amphoteric. So it's an or. So it's not conclusive. Imagine I'm doing this. But if it doesn't dissolve, I actually know immediately is what? It's a sand. Agree? Acidic, right? They don't react. Make sense? So have we solved it? Not yet, because if it doesn't dissolve, I know. But if it dissolves, I will know. So I need to run another test to sort this out. Make sense? So what else I'm going to do? This time around, I add alkali. Use the basic, the common one, right? To the solid sample. But got problem there. If it dissolves, then you still got solid sample, man. Visualize, Chemistry is not memorized one. You understand what I'm saying? If it dissolves, then you got no solid already. Make sense or not? Then how you add sodium hydroxide react with what solid? No solid already. Are you with me? New solid sample, but there's only 1 solid sample. So what I do in the exam, thank you. I add 1 more word. I split the solid sample into 2 portions. I told you cannot be memorized. You're supposed to play with it. So I will add in inverted V, add nitric acid to first portion or 1 portion of solid sample. No basic can know inverted V in the exam. My geography always inverted V. Or squeezing keywords. All right. Then this one add to another portion. Or the other portion. Right? And therefore, we can solve it already. So either it dissolves or it doesn't dissolve. Right? If it dissolves between these 2, who will dissolve? Sodium hydroxide. Answer is oxide. All right? Because it's amphoteric. If it doesn't dissolve, it's MgO. So ladies and gentlemen, by using acid and alkali, I have sought out or rather I can investigate the white powder, is it MgO, Al2O3, or SiO2, purely based on my understanding of the acid-base properties.